So another topic in what we need to pick up on is the different types of probability that we have. So the types of probability that we're going to be working with, the first one's going to be described as classical. The thing about classical, everything's going to have this concept of equal. Each outcome has an equal chance of happening. The other one we have is what's called empirical. A lot of times it's going to be coming from surveys and things like that. What we're going to see is there's not this equalness in it, not equally likely. So the outcomes will have different chances of having. This is when you get into those frequency distributions and pie charts and things like that. The probabilities are all different. And then we have what's called subjective. Subjective is more about intuition. Okay. So classical is kind of more traditional when you're playing like games and things like that. Empirical is more like when you're doing some type of survey or you're gathering information from somewhere and you're using that information to make a judgment. And subjective is just it's kind of more your gut feeling than it is anything else. So finding the classic probabilities. So when it comes to classical probability, notice how we're going to start using this notation like P of E. P of E is going to equal the number of outcomes in event E divided by the total number of outcomes in a sample space. So notice how there's going to be this counting thing. We're going to have to determine how many outcomes are in the event itself. And then I also need to know the total outcomes that were there all together to begin with. So this is kind of more of this concept of part over this whole concept. It's kind of fractional thinking. So remember this, an event is more of a subset. So we got this is usually a smaller part of it all. So this over here kind of stands for the probability of an event happening. So this capital P stands for probability. And then in parentheses, this is the event we're referring to. So they'll use some type of capital letter there for the event. So up here we have event A. So we're talking about rolling a six-sided die. So the six-sided die, as far as outcomes go, we have 1, 2, 3, 4, 5, 6. That's a sample space. In other words, there's going to be 6 outcomes altogether. That's my sample space. Okay, so the total outcomes. So event A is rolling a 3. Well, that's a simple event. So notice how that's just going to be a 1 chance out of 6 chances. So my probability is going to be this 1 in 6. So let me get my calculator out because I think a lot of times they're going to be using, so lost that. Let me try that again there. Let me pause my video for a second, get this a little bit more organized. Okay, so the rolling a 3 was only one possible outcome if I'm looking at my outcomes there. So 1 divided by 6 was what we ended up with there. So if we put that as a decimal, it's going to be like 0.166. It's got a bunch of sixes there, but remember, usually right now we're rounding these to 3 decimal places. So 0.16, and then what that third number's got to be is I have to look at the fourth number. So I've got 166. That fourth number is a 6. That means we got to round the thousandths place up to the 7. So remember, the 1 is in the 10th place, the 6 is in the 100th place, the 7 is actually in the thousandths place. So that actually now read as 167 thousandths if we were reading it. So that would be our probability in the form of a decimal. If I move the decimal 2 places to the right, we'd say about 16.7% of that happening. So, if I was trying to roll a 3 on a die, that's not going to happen that often, but it does happen. Okay, so it's not impossible. As far as gambling goes, 20% chance. There's probably some good odds on it. If you ever play with gaming, there's odds on that. The higher the risk, the bigger chance of winning more money. So the event B is like rolling a 7. Well, remember, the only outcomes are in our sample space are 1, 2, 3, 4, 5, and 6. Is it even possible to roll a 7? That's not even going to happen. So that outcome is not even possible. So it's going to be a 0 out of 7 because it doesn't even exist in our sample space. So 0 divided by 7 is just going to be a 0 chance or a 0% chance of winning there. So the event C is rolling a number less than 5. So less than 5 kind of means we're talking about this 1, 2, 3, and 4 because we can't be 5 or 6. So that's how there's 4 out of 6 there. So the possible outcomes in the event are those 4, and then the total sample space was the 6. Now, if I reduce that, that's going to be 2/3 as a fraction. So remember, in my lab, they want things simplified if it's a fraction. As a decimal, if I type in 2 divided by 3 or 4 divided by 6, I'm sorry, 2 divided by 3 or 4 divided by 6, I can't mix the two together. We should get this 0.666. So that's going to just turn into 0.667. So let's say, you've got a 66% chance of rolling a 1, 2, 3, or a 4. So you probably aren't going to get great odds on that. So keep that in mind. So that's what we call classical probability. So there's going to be this distinct sample space, and we're going to be dealing with this subset or this event that's coming from that subspace, that sample space. So it's called a classical classical probability. So let's see if we can get this to fit on our screen here. Let's see here. Make that a little bit smaller. So another type of game that we play, instead of just flipping a coin heads or tails or rolling a die 1 through 6, there's also a standard deck of playing cards. So a standard deck of playing cards has hearts, diamonds, spades, and clubs in it. These are called suits. And then as far as the cards that are in it, you have like the hearts, there's going to be a 2 of hearts all the way up to a 10 of hearts. And then you have these face cards, Jack, Queen, King are face cards. And then you have the Ace of Hearts. So there's actually 13 hearts. There's 13 diamonds, 14 spades, and 14, or sorry, these are all suits of 13. 13 hearts, 13 diamonds, 13 spades, and 13 clubs. So that's a total of 52 cards, if you will. So let's see what we can do with these cards. So you select a card from a standard deck of playing cards, find the probability of each event. So again, notice how this is my sample space. So this is going to be what we call classical probability. Selecting the 9 of clubs, notice that the 9 of clubs only exists one time. So that means there's a 1 in 52 chance of that happening. So if I use my calculator and divide that out, 1 divided by 52, that's going to be like 0.019. So 0.019. So if I move my decimal over, that'd be like 1.9% chance of that happening. So if I threw a bunch of cards out and randomly selected one of those cards, the probability of that would be a 9 of clubs would be about a 2% chance of that happening. Not likely. So event E is selecting a heart. Well, notice how we have 13 hearts. So my subset or my event is going to be 13 hearts, but the total number in the sample space, the total number of outcomes is that 52. So what I have is this 13 divided by 52. Now that actually does reduce down to 1/4 because 1/4 of the cards are hearts. So I actually could probably do that without using a calculator. So 1/4, because there's 1 of 4 there, that's actually going to be 0.25. So I don't need a calculator there. So 25% chance of being a heart. Event F is selecting a diamond, heart, club, or spade. Well, that's our whole sample space. So that means that's going to happen. That's going to be a 52 out of a 52 because that is our subspace. That is our sample space. So it's going to be a 1, or we could say 100%. That is likely to happen because remember, 1 if you move the decimal 2 places over would be 100%. So that's what we'd have there on that. So that's what we call classical probability.